Welcome to lesson 1.2. We're looking at examples 3 and 4 using definition of segment bisector and midpoint. A segment bisector is a line or point that cuts a segment into two equal parts. To bisect means to cut into two equal sectors or two equal pieces. So the idea is I have a segment, AB, and either by some line that passes right through the middle of it or some point that sits right on it. Here's A and here's B, and we'll call this point P. It ends up cutting it into two equal pieces, so two congruent pieces. We'll call this line L. Line L bisects AB, segment AB, giving us the following result, that AP, the segment AP, is congruent to the segment PB. Don't worry, we won't put a J in there. Or I could also write that AP equals PB. The distance from A to P equals the distance from P to B. If it's bisected, I can draw either of those conclusions. Midpoint is a point that bisects the segment. It is the point in the middle that bisects a segment. So in this case, P is the midpoint. And once again, if P is the midpoint, then the following conclusions could be drawn: that the segment AP and segment PB are congruent. Also, the distance from A to P equals the distance from P to B. So here's an application of a story problem. The map shows a route for a race. You are at X. X is 6,000 feet from the first checkpoint, C. So this is 6,000 feet. The second checkpoint, D, is located at the midpoint between C and Y. So D is the midpoint between C and Y, which means this piece and this piece are equal. The total race is 3 miles. How far are checkpoints? How far are the two checkpoints? I don't know what these distances are, but I do know they're the same. So if I call this one X, then this one is also called X. And we'll put them in feet because this is 6,000 feet. So right now, if I want, using the segment addition postulate, and thankfully it doesn't say to write this as a proof, but XY, the whole thing, is XC plus CD plus DY. Those three segments added together. So XC is 6,000 feet plus X plus X. So on the right-hand side, I have 2X plus 6,000, and this is all in feet on the right side of my equation. On the left side, the distance for XY that they gave me, the total race, 3 miles. The problem is that that's in miles and these are in feet. So I need to convert the 3 miles to feet. So I'm going to say, all right, what's the conversion for miles to feet? 1 mile is equivalent to 5,280 feet. By doing this, by multiplying by 5,280 feet and dividing by 1 mile, my miles units cancel, and I will be left with the units in terms of feet. So I have 3 times 5,280. 3 times 5,280. You will need to know that number. Maybe you don't know it right now, but you will need to. We're going to use it a lot this year. So that means that the total race, XY, is 15,840 feet. So now that I have an equation and everything's in terms of feet, I can solve. I'm going to subtract 6,000 from both sides, giving me 9,840 feet equals 2x. I'm going to divide by 2. X is 4,920 feet. What did they ask? How far are the two checkpoints? C is a checkpoint, D is a checkpoint. That's the first, that's the second. So I only need C to D, which is X, and I already have that. So CD equals 4,920 feet. Had they asked for the distance from C to Y, I'd have to double that number. Last examples. We're going to look at example 4, using midpoints to set up equations and even to write them as proofs. This time it says D is the midpoint of EF, so I will begin by drawing segment EF, and I will put D in the middle this time. Oh, that's an F, because it says it's the midpoint. If it doesn't say midpoint or bisected, don't do it. If it said D bisects EF, I could do the same thing as if it says D is the midpoint. So ED is the expression 4x plus 6. DF is the expression 7x minus 9. And they didn't give us a whole expression, so I can't say this plus this adds up. It does. This plus this will add up to EF, but I can't say that right now because I don't have an expression for it. But I do know that it's the midpoint, and if it's the midpoint, then ED, the segment ED, is congruent to segment DF, which means, by definition of congruent, and I'm going to let you just write this without writing definition of congruent, ED equals DF. And we're going to write that as step 1, definition of midpoint. You're technically supposed to write that the definition of midpoint is that they're congruent, and then that they're equal because of the definition of congruent, congruent being equal in measure. But we use this so much in here that we kind of skip that step, and it's okay for our class to say we're going to skip that, and just whenever we say that they're equal for purposes of equal, we can use definition of midpoint, or if we're saying they're congruent, as long as it was given, oh, that should actually have been my line 1. Sorry, we're going to number that too. D is midpoint. I'm going to circle this and put it right here and write given. So the fact that it's the midpoint was given, I'm saying they're equal because of the definition of midpoint. Now I'm going to plug stuff in. So 4x plus 6 equals 7x minus 9. That's substitution. I'm going to subtract the 4x to get that to one side. So I have 6 equals 3x minus 9. And then I'm going to add the 9, so I have 15 equals 3x. And then I'm going to divide by 3, so I have x equals 5, or 5 equals x, actually. The reasons being, we go from here to here, I subtracted, so subtraction property of equality. And then from here to here, I added, so addition property of equality. From here to here, I divided, so division property of equality. Now there is one last step, and I'm not going to fit it in here, so I'm just going to leave my proof there for now. I'm going to write down that ED, and this is all by substitution, is 4x plus 6. DF is 7x minus 9. And EF, by the segment addition postulate, is ED plus DF. So I can get that answer as well. So those two are by substitution. You can see we're plugging it in. This last one I'm getting by adding the two together because they didn't give me an expression for EF. Our value of x was 5, so that's 20 plus 6, that's 26. 7 times 5 is 35, minus 9 is 26. 26 and 26 is 52. And since I don't know the units, I'm just going to put U for units. All right, letter B. Now, instead of saying S is the midpoint, it could have said S is a bisector, and then I would write definition of segment bisector. But they told us it is the midpoint of RT, so I'm going to start that with line 1 being the given. Because it's the midpoint, I know that RS, oh, we better draw this picture because we have a problem here. It says S is the midpoint, so I'm going to put S in the middle and mark those congruent, of RT. They give me an expression for RS as negative 5x over 4, and an expression for RT of negative x over 3 minus 2. There's actually a couple ways I could set this up. I could say 2 times this, since those are congruent, equals this. I could say this is equal to half of this whole expression. Or I could rewrite this. Since these are congruent, this also has to be negative 5x over 4. If I want to, I could do it that way. So I'm going to have RS equals ST, definition of midpoint. Now, I can't just set them equal because they're the same expression. But I can do RS plus ST equals RT. And notice here, even up here, I could write equals negative 5x over 4 because that was partly given. All right, so now for line 3, that's actually the segment addition postulate that we're using. And now I can write my equation, negative 5x over 4 plus negative 5x over 4 equals the opposite of x over 3 minus 2. That is substitution, because we plugged it in. And now, yay, we have to deal with fractions. So I'm going to multiply everything by the least common denominator, which is 12. And you can do anything, any work you want between these, but your next line will be what your equation is. So because I'm multiplying both sides by 12, this is going to be multiplication property of equality. So when I do this, this is, that's going to be 3, so this is negative 15x, that's going to be 3, so it's negative 15x, that's going to be 4, so it's negative 4x, and that's going to be minus 24. Oh, I forgot to put the equal sign in between them. That's right here. So this will be, now I'm going to go do my next step. So when I do that, I'm going to combine like terms. That's going to be my new equation, my new line. It's negative 30x equals negative 4x minus 24. I combined like terms. Now I'm going to get my variable to one side. Because the 24 is there, I'm actually going to add the 4. So that'll be negative 26x equals negative 24. I feel like I did something wrong, but maybe not. So we, how did I do that? I did the addition property of equality. And so now I'm going to divide by negative 26. Let me just look over this real quick 1 second. From what I see, it looks right. So now to solve for x, I'm going to divide by negative 26. Negative 24 over negative 26. Both are divisible by 2, leaving me 12/13. And so that is the division property of equality. Now there could be more lines to our proof, but we're running out of room here. And the final line, which I'm going to do over here, is going to be substitution. So I'll write it right there. Substitution, because I'm going to be plugging 12/13 in for these expressions. So that means that RS is negative 5 times 12/13 divided by 4. Divided by 4, which gives us negative 15/13. RS is negative 15/13, which, again, I don't really like this. We shouldn't be getting a negative answer for these. This is probably a bad problem. But we're going to say that that is negative 1, roughly negative 1.15. And then for ST, we have the same expression, negative 15/13, which is negative 1.15. And for the whole thing, RT, we do have an expression. So I have the opposite of 12/13 divided by 3 minus 2, which is, as a fraction, negative 30/13, or roughly negative 2.31. So I'm just going to double check this. Negative 1.15 plus negative 1.15 is not going to add. Oh, it does. Adds up to negative 2.3. So we did solve right. It's just a problem involving fractions. Now there's one problem that I don't like about this, is that we're getting negative numbers. So really this is a bad thing, that we should be getting positive values for distances. But how we set up the problem, how we write a proof regarding this is the same process. This concludes the video notes for lesson 1-2. We'll be doing some of the try-its in class. Have a great evening.